Thank you, Greg, and very nice to be here in front of you. My talk is supposed to be short, even though, you know, profs, they like talking and so on and so forth. I hope we engage into some kind of discussion because I want to pick your brains and get your ideas. I'm going to give a talk about, you know, data science as a practitioner. I'll start with a few words about myself. So I'm engaged with data science activities for a long time. It existed before the term big data became a buzzword. Oh. All right, so
I guess it's on the record now. I should not use bad words. So this company here, SumUp Analytics, is about doing text analytics, and then this other company, which I'm, you know, an advisor to, is involved in big data for energy market, financial markets and energy. And I've done my stint at hedge fund, now defunct, and I evaded the prison, so I'm very happy to be here. These activities, these consulting activities here, mainly touch upon, you know, big corporations trying to figure out what to do with big data. And so I hope, you know, I hope I can reflect on those and get your ideas about that. It's really for a major corporation, like I know very well this retailer, number 3 in the world, Carrefour. They have lots of data, but they're scared, like, you know what, about what to do. What is the big data strategy? And they're very conscious of that, but they're also conscious of the many traps and booby traps are around those issues. So the nomenclature that Greg was referring to is basically this. And my challenge, I mean, who heard about these terms? And does that, you know, so for those of you who heard about those, it'll be just a simple walkthrough. If you never heard about those, it's going to be the first time. I'm going to try to make those concepts palatable, but feel free to interrupt, because I think it's very important as you enter, you know, a managerial position and start thinking about big data strategies to really know some of those terms, because otherwise you can, one, be taken for you know, a ride with data scientists that try to sell you something. And second, it's very hard to understand what is beyond the buzzword if you just read the mainstream press, I noticed. So, you know, unsupervised learning is basically, here's data, do something with it, find insight, actionable insights, and so on and so forth. You heard all these phrases. And data from a big or data scientist perspective, they're all the same. To me, all these are numbers, but the context, of course, is very different. This is in the context of angioplasty. It's a particular surgical procedure where you have to cut things, but not the wrong ones. This one is about voting. So this is a Senate voting data. At that time, President Obama was then a senator. If you look at this, you're lost. If I don't tell you the party affiliation, no way you can see any structure. And this is even worse in markets. If you just look at raw data, there's no way you can even understand anything. So the goal of machine learning is really to help. It's not just to sell software. It's not just that. Basically, this is a traditional MRI style, you know, image that the surgeon classically would use. And this is the same image, same data, processed through machine learning. So, you know, it doesn't sound like so much, but it's make or break in terms of surgical operation. And there's been a ton of progress in the image world, where how you remove noise, how to extract the right features that you want. But it extends beyond images. When it comes to voting data, for example, again, imagine you give the machine this array of yes, no votes. And those guys, I think they were just sick or something. And I don't give you the party affiliation. It's just a case study to see if big data has anything to offer. At least it should tell me something that I already know. So that's an exercise in communication that data science has to do all the time. And the result would be that you come up with a score that magically discovers that there's two parties, and further, that can rank the senators against a party line. So you could say that Senator Feingold is a Democrat, but she's near the center, whereas I can't read. Senator Sessions is more on the Republican side, more strongly affiliated with a very strong Republican bent. Is that true or not? Well, I'm not a political scientist. I can't say, all this ranking makes exactly sense. But people have told me, yes, there's enough political scientists on campus to tell me it does make sense. Here, what is the big data thing is that this ranking is just discovered by the algorithm. That's what you want. You want to discover something. In this case, that thing is not new. But to me, it was that not only do I recover the right sides and the parties, but I recover what is inside the party structure, who is more towing the party line than the others, who is reaching out to the other side of the aisle. So you can do much more than this. This is just one example. Now, a little break, take a breathe. We're going to do math. I'm going to explain to you a very important concept in math with just pictures, and it's going to be applied to this. We're going to try to understand how you can understand what's going on inside data. And it's just going to be a placeholder. Next time you talk with a data scientist, he or she cannot just impress you so easily with buzzwords. So the buzzword here is unsupervised learning. I'm taking raw data. What are those, by the way? They're called log returns, just a measure of if you invest $1 today in Microsoft share, tomorrow how much you get. And this is the main thing that portfolio managers use to invest, for example. So here's a simple view of the world. Imagine that all the stocks, they were exact same copies of each other. That would be very simplistic, right? Let's modify a little bit our model because that model is clearly very simplistic. Let's just pretend that instead the market was entirely exactly like this. There's one stock here that lives its life. This one stock is exact copy, but it's scaled down, and so on. All the stocks are copies of each other, but scaled by a number. Could be negative, in which case the time series flipped around. That would be very simplistic. Well, the catch is it's simplistic, but not that simplistic in the sense that it's a pretty good approximation of what's happening. But it's not good enough. So what the math people have devised is so-called factor model. Now, this is $100,000 a year math thing. I'll tell you why. This here is the real data. It's a bunch of time series. And the factor model says, to a reasonable approximation, this whole complicated, noisy stuff is really made up of a sum of different pieces. Each one of them has one driving factor, and all the other ones are copies of each other. So it's like when you see light, you know that you can decompose it into different colors, and really the light you see is the sum with different weights. That's exactly what this is. Or sound, it's different frequencies. That's exactly what it is. And this notion of decomposing complicated things into a bunch of simple things this way, this draws back to the 19th century physics of sound and light and heat. But in the 20th century, people had the brilliant idea of saying, well, it is not married to physics. It's really a general concept I can apply to psychometrics, students, grades. That was the first installment in the 30s of this concept. And then later people said, well, let's apply it to market. And there you go, you have your Harry Markowitz. I don't know if you heard about this guy. He won Nobel Prize, essentially using this concept to understand what is the risk in a portfolio. I won't go into those details, But when I said this is worth $100,000 a year, is that there is a company actually based in Berkeley, since then bought by Morgan Stanley, MSCI Barra, that they sell a factor model, slightly more complicated than this one, but basic idea is there. $100,000 a pop, you get a monthly update. So if you want their factor model, just pay that amount. And all the major institutions, financial institutions in the world, they do that. They are subscribed to that service. So that's a big data business built, but it's an old business. I mean, it's been around a while.
Founded by a Haas professor.
Yes, Bar Rosenberg, and I don't know who the other one is. Exactly. So a very good success story. Now, how good are these factor models? If I go back here, you see there's two factors here. I could have any number of them. But the more I add, and that's the data algorithm, the unsupervised learning algorithm, I can compute these things unambiguously with a machine on a laptop. It scales up to thousands and thousands of stocks. No brainer. This is not big data. You don't need a cloud computing architecture to compute that. It can be done here. You can compute more and more, and the more you add, the more precise your model is. The more precise or true this equation becomes. So you can count when do you stop. Well, if you want to only stop at 10, you explain 80% of the signal in a sense that can be made rigorous. And then when you look at those coefficients of those different factors, you look at those, many turn out to be very small. The big ones identify rows here, which are companies. So now you can look at the important companies that drive the market. Those are the companies at that time. This is a period just before the crisis. And so people looking at that data, just not knowing anything about the market, could say, well, it looks like the major drivers all move to banks. That's what happened. If you have a big data mind, you can not read the newspaper, just keep on doing your factor model and monitoring those things. And you see there's a diagnosis, a risk diagnosis capability in that approach. Any questions? Have you heard about factor models? It's called principal component analysis.
We're saying there is that you can predict a single stock by using those coefficients?
Very good. It's not exactly that. You cannot use this for prediction. This is looking back because, and we'll move to that question. You cannot, it's just like, here's the data, understand it, reveal party structure, understand what drives the market. It's not supervised. In supervision, we'll have prediction. Very good point. Any questions?
So, because machine learning is basically a commodity now,
Yeah.
Why do people pay for things like Barra factor models or for FICO scores when you can just engineer your own models more or less for free?
Yes.
If you have access to the same data that they have.
I think you would know the answer better. I think really the data collection and cleaning process, it's really a difficult one. Barra brings about a lot of economic insight or an economic data insight. So it's more, I think the challenge is aggregating the data, maintaining, curating, and all this is just not worth for a bank. Would have to pay a full-time engineer, so 300K gone. Instead, just pay Barra and you don't worry about it. But you have an excellent point, because if companies would start developing inside capabilities with respect to that, they have a much better handle on, it's not like secret sauces, and so they can rely more. So I think the tension you're evoking is very important. In-house is always better if you can afford it. But it's striking, right? It's kind of simple, the service there. So in voting data, I already commented here. So to summarize, unsupervised learning is, here's a bunch of data, just analyze, understand. So it's kind of vague. You can hear that what is getting insight, well, you don't know, and you're fishing for something. It's a more challenging part. I would say less grounded in a target than predicting something. So that's the supervised learning part. So here this text is just to put words on what supervised learning is. But basically a typical thing is you are given data and side information and you want to predict what is the next side information. Let me give you an example. Bank loans. When you apply for a loan and you see there's companies that now, FICO scores, all this, it's a very big industry of predicting what people will do based on data. So you might have a huge database with many, many columns and as many rows as customers. And when they apply, you can monitor 6 months later, did they default? Yes, no. So that's your training data. You're going to give that to a computer which will do something with that training data, exploiting not just all these so-called features, but also the side information that you want to predict. Let me make that a little clearer. A new customer comes in. Are you going to award a loan or not? Well, you don't know yet if he or she will default in the next 6 months. You want to predict that. That's the side information which you don't have for the new customer, which you want to predict. And so how is it done? Again, a little bit of a detour math. It's done very simply by putting all these customers representing as points. So imagine that instead of having many columns, many features, you'd have 2 features, let's say age and income. Then you could plot all your customers, your existing ones, your training data on 2 axes, age and income. Of course, in reality, you don't plot anything, you let the machine do this implicitly. And also there might be a 3rd dimension, a 4th dimension, it might be 100,000 dimensions. In fact, I've looked at, Lending Club? Lending Club, they have not only data on age, income, that's very classical in the loan industry. They also have a little text that says, yes, I want to make a loan for my wedding, or I want to get money for my new car, or something like that. And text itself is a dimension in that space. I'll revisit that later. So the point is once you have your points, you now can color whether or not they defaulted or not. And then what the algorithm, the machine learning does, is to try to draw a line that separates these points as much as possible. Of course, it cannot be done perfectly, but roughly. And then what happens is a new customer comes. Well, depending on where that new customer falls, this is the age income plane, you will decide if it's on this side. It's a green, I go for it. Okay? So it seems simplistic, and it is. There's not much more to it. Well, not so. I mean, I shouldn't say it. I'm shooting myself in the foot. So in fact, what is more, I tell you now the last piece about machine learning. I'm telling you an example of what is at the frontier of that field. Well, the frontier of that field is the following. You see in that setup, these things are features, are dimensions in some kind of geometrical problem, but they're features as they're known. And they're based on the bank's decision. What will we ask in our questionnaire to the customers? We ask his age because we believe age is relevant. We ask this. You don't ask astrological sign, right? Well, you could infer it from age. But it's not seen as a feature, right? Astrological sign. Or here's this one. The number of denied withdrawals in the past 6 months. I had no idea that banks would think about this being a feature until I learned from a customer of ours that, they have this column. So what are the right features? Well, it's not an obvious thing. Look at these 2 things, 2 examples of why feature engineering is important. See, these supposed to be my drawing for a financial time series. Imagine that I take the financial time series and I shift it backwards or forward. Basically, they're the same, right? They're just delayed version of each other. Well, my model, the thing that I described you where you analyze factors, it doesn't handle that very well because it thinks, basically what it does is it implicitly compares time series by the difference at any point in time. You see, they're always different, never the same. So there are things that you can see there's a similar structure or pattern that depending on how you tell the machine that how you encode time series, in this case, time versus value pairs, depending how you do it, the machine will understand these two things are similar or not. In images, you can see that all these images are the same because you're human. We are so trained into contextual representations that we know that even though the pixel values of these two images are very different, if you look at the difference between the pixels, they're going to be like this, very different. But there's a structure there. There's a feature inside that tells it's a cat. What are the features of a cat? So, long story short, now there's technology that if you feed enough data to a particular kind of algorithm called deep learning, you will end up by being able to identify the cats in a library without ever telling or even understanding what the computer thinks is a cat. I mean, it's kind of a self-referring loop, but it's a fantastic feat. Now, when you apply it to markets, it's not such a successful story. When you apply it to text, it doesn't work well yet. So it's a technology in development. I think it's a very interesting one, intriguing, because it says to the bank, we're going to take your data that you have collected already, and we're going to extract the right features. Maybe it's not the age and income, but it's a weird combination of the two. And that's the one thing that you can infer. Okay, so that is all about machine learning. Once you understand these two distinctions and the frontiers of it, you have a grasp, I hope, of what's going on in that field. This field here is also part of the same area. It's a field I really like because it builds on this to now recommend a decision. So typically when you do machine learning and you read the press about that, typically you would think that, well, machine learning is all about predicting what's going to happen to my customers. Actually, there's something downstream where you predict something, but then you exploit that prediction and you let the computer help you make the right decision, more than just predicting. It's as if, okay, where are you going to invest tomorrow on the market? Here's a budget of $1 million. What are you going to buy? Well, there's a machine that goes back, uses machine learning to predict where the different stock prices are going, and then based on that information, the Bara thing will tell you where to allocate your budget. That's called optimization, and it's a very important piece of the big data equation. But I would say it's a little bit under the hood right now. I don't know exactly why. It's historical. Okay? So for example, I worked with Walmart on a problem like this. They have billions of items because they actually bundle items. So you have an explosion of very large portfolio of items they sell. And you have demand for those items. So they can use machine learning to estimate based on past data how much demand will it be for every group of item. And then based on that demand, they have a pricing mechanism. They will price it, and then hopefully they will manage, how much price change they tolerate. Maybe they don't want all their items to change prices all the time. Perception of price being a constant is good for customers. They have all sorts of constraints, and so that's the optimization side. Okay. Originally, there was a bug. Of course, it's not my bug, but at some point, the Walmart, they were in a rush because of Christmas. They said, let's implement it. So there was a discussion. No, let's go for it. And they started selling flat screen TVs at $9. So they lost 400 million on that one. So, any questions?
So in business decision making, how does the kind of these new capabilities in big data replace or augment a Monte Carlo simulation or other kind of prediction tools?
In fact, they don't replace, I would say, Monte Carlo simulations, it's part of the toolkit. And it's just that now we can do it at scale for 9 billion products. We can do all sorts of things. But I think also there's a discussion I want to have at the end. I mean, a lot of people think that it's restricted to being an operational tool. Like, you know, these guys, they're all very close to the operations. It's not like the CEO is going to look at the numbers, right? So I think there's the Monte Carlo simulation is about, you know, you have a model of how things might evolve, and then you let it run to see where it falls. And so this is where the nice meat, the tension is. As a future, you know, decision maker at the strategic level, it's good to know that it's not just about operations, even though the strategic part is difficult. It's not like it's solved problem. These problems are more or less solved. You can improve on them and correct the bugs, but to have an impact on the decision making, I think is really the exciting part.
But you're building a better informed model, basically, with more data.
Yes, and also I'm a strong believer at a more strategic level to have a lot of different inputs, like, you know, classical models in finance to predict what the stock market is doing is look at the past price, maybe volume. Now you can look also at Twitter, you can look at all sorts of different inputs. So I think where it informs decision making is still unclear, but there's a very strong need for, let's say, better information. So, you know, it's all, this whole tension is there.
So there's been some critiques on the machine learning or deep learning algorithms that they're kind of black box, and if you want to act on them, you're not really sure what to do.
Yes.
Like there's like 500 layers, and how can you act on those?
Yes, me too.
Versus some of more like what you said in a bank loan, where you have, say,
Clear
things where you can act upon.
Yeah.
So how do you conciliate the two?
Yeah, I think it's a great point. That is there's a field of machine learning called sparse machine learning. I'm a great fan of this, which is all about interpretability, because machine learning in the end, and I think I saw a talk, I'm not sure if it's this year or that last year, that says it's related to storytelling. You have to be able to relate a story. And in that bank loan project, we have to say, well, you know, we discovered that those are the important features. It's not like a black box that processes. It's not, sometimes it is, sometimes they don't care, but most often they care about understanding what the process is. And that ties to this strategic question that you need to be able to explain what the box is doing. And there are techniques that say, you know, not only do I you know, if you go back to that thing, not only do I draw a line, I don't understand what it means, you know. I'm able to explain the decision rule with words to say, well, it relies only on 5 features, for example. We have identified that you just need to look at 5 features. So, for example, in medical, you know, if you're trying to trace you know, genes to diseases, for example, you say, okay, these 10 genes are responsible for that, not a combination of 100,000 genes. I think that's what you're alluding to. It's a very important problem. It's a challenge, but it's recognized by the community as being one. So there's things. I'd just like to conclude my little tour, and then we'll go on discussing the question. This is about text analytics, so I'm quite interested in that area, if only because, you know, I know, for example, big-time portfolio managers that, you know, run multi-billion dollars hedge funds. They read news, right? They want to know what happened at Doha with the Saudis. They want to know all these things, and so they read. And they spend 2 hours reading. So I thought, well, that's a lot. 2 hours of this guy, that's a lot of money every day. So I think there's a need to summarize text, but not just one piece of text, but many documents, okay? So,
And I think a lot of text now is actually written by computer based on, you know, a couple bullet points. You feed in some data and then they turn it into text, and then when you try to read it, you try to convert it back into those bullet points. And
Exactly.
It seems like it's sort of a inefficient process.
right, just give me the bullet point.
Yeah.
Yeah, and this whole thing of summarization is not a nice sentence Shakespeare style. It's more like bullet points. Okay, so how would you summarize who Nicholas Kristof is, or Roger Cohen? There's a famous columnist in the New York Times. How would you summarize? Well, bullet points. And I can count words. Unfortunately, the font here in blue, this is Roger Cohen. And this is in a particular period where they're all talking about the elections at that time, 2008 presidential elections. And of course, you see a lot of common words in red, which tells you that you are not just by counting the frequent words getting at the essence of what distinguishes these two things. With modern statistics, though, you can get other words that are more distinguishing, and then you realize that Nicholas Kristof is very interested in, you know, human rights issue and also innovation, Facebook, and so on and so forth. Whereas Roger Cohen has a very different, you know, angle to things. And so this is a discovery process that, you know, you can go beyond. Like, for example, if you type Amazon on Google, this is, to me, not satisfactory, because unless I know already what I want, I have 34 million results, so they say, which is not true. If you try to scrape them, they would block you. But in other words, they just bombard you. Here's the fire hose, you deal with it. And ideally, what I would like is to break down Amazon into nice topics that I can understand and a few documents. And unfortunately, I wanted to show you a demo, but I tried the access. I don't have it, so I don't know. I'll share the information. I mean, if you want to try later, I don't know. But essentially, what the text analytics part is, here's a lot of documents, let's say about big data, run it through some kind of factor model that works for text, and then it'll give you the major factors or topics with the major things that you need to read. So in a database of 60,000, you get with 50 documents to read that span the whole thing. That's the kind of things that text analytics does, unfortunately. So for example, you could have little maps where you have, this is a corpus of Wall Street Journal, how they talk about different countries, in this case Libya. It's at that time where Gaddafi was still there. And you know, these are the words that are distinguishing of that country. So very quickly you get the gist of what the conversation is, and normally this would display below the few articles that you need to read about Libya to just get just an idea. Of course, we kind of all know Libya, or we heard about it, but sometimes, you know, if I want to describe the situation of shale oil companies in the US, maybe you don't know about shale oil companies. You don't even, I mean, I didn't know. So that is a shortening the time to get information. All right. Any questions about text analytics? All right. Yes?
Is that how those, you know, hedge fund managers want to receive, you know, their 2 hours? You know, is that 2 hours they enjoy it and they are used to processing it in, you know, paragraph form because they deal with numbers and bullet points all day, or, you know, how do they want to receive that information?
To tell you the truth, I'm discovering. So I'm proposing to them stuff, and they are telling me yes, no, or one of the things that they're very interested in is in translation. So once you summarize a whole corpus by a few keywords and a few key documents, then it's not costly to just translate that. So they want to know what the Russian press says, you know. So that's the goal, but it's in development, yeah. So I just wanted to let, you know, the same way I gave you the building blocks of machine learning or more generally, you know, data science, I think there's other building blocks. You might have heard about these things, right? I mean, people have discussed it. And to me, they all count. So, there's many phrases I read, and I'm paraphrasing what I read, but basically the perception that big data is about very massive databases, it's true, but partly. Sometimes you have small data set that has a lot of value. Loan data, it's very small, it's 2 gigs, nothing. But there's a lot of value because if you improve on the estimation of probability of default, that's an immediate impact on the ROI. This sentence here is I'm trying to fight against the latest buzzword. It used to be Hadoop, and companies spent millions on Hadoop infrastructure. Don't get me wrong, Hadoop is great, but it's not solving your data problem. It has to be a whole thing, not just a single mode du jour. So here, right, this is just because I train engineers, and then if I send them to a customer, it's a catastrophe. They can be very good in Python and so on, but they would end up giving you the graph and letting your brain understand what the graph is. Back to interpretation. That's why there needs to be, great storytelling. And I noticed, for example, that the engineering programs, including at Berkeley, unfortunately, is not conducive to that. We're not training correctly those engineers. I think the best way is to pair it with people like you. That's why companies that have a Rolls and a Royce, I mispronounced, but Rolls-Royce, you have the business guy and you have the engineer. That, to me, is the key of a key of success. So I encourage you, if you want to start a company, come over and shop for such things. There's mechanisms to do that. So a lot of you hear all the time in the press actionable insight, and I want to fight this because sometimes it's not clear what the action is. Let's say you understand better your customers. Let's say you understand that the customers, want to go in a certain direction. Like I remember one was, they want organic meat in your stores. Well, organic food chain is a very complex, huge decision. So you might not lead to any actionable decision, but now you know that they're interested in that. So maybe you can alleviate this, but not like make a big decision. And of course, there's the dictatorship of ROI. And so again, I think it's better to replace that. I don't know. These are other sentences. I don't want to push too much on this. I have a few themes that I've been meeting with, but I'd rather open the floor to your thoughts and comments and ideas.
So say you have a model that has 6 features to predict whether a person will default or not. Is there a way that a machine can help you define what is the 7th feature, or is it still a human decision that has to rely on like business understanding and intuition?
It's a very interesting thing that you're raising, which is like, it's actually ranking the features. It's not just, so if you're talking about, I have a potential big list of features, rank them, yes, that's very easy to do. But if you're just shopping for features and you have no idea what the features would be, like I have this project with market data, frankly, I don't know what the right features are. Is it technical indicators? Is it, I don't know. So now it's deep learning and it's complicated and it's, but not to say that you can't do it, but it's still at the edge, I would say.
So I'm wondering if you comment a bit about the balance between kind of trusting the algorithm and trusting your business judgment. I think a lot of the message that we've been communicating here at Haas has been, to lean more on trusting the algorithm and to understand that you can come in and with data tools override sort of conventional wisdom in a lot of industries. But there's also the error on the other side. So I saw a talk recently from the chief data officer at Uber, and they were introducing a new interface, and they used an A/B test. And the new interface was underperforming the old interface. but they understood that it was going to take time for the riders to learn the new interface, so they extended the experiment, and ultimately the new interface prevailed. Or if you think about, for instance, the banks in 2007, 2008 that were using, say, 12-month VAR.
Right.
You know, because just sort of out of habit, and then trusting the output from the models that came out of this, as opposed to maybe using some historical insight that would lead them to not underestimate low probability events. So how do you optimize the mix between human insight and the data science tools that we have at our disposal?
It's really a tough question. I'll give you a little anecdote that doesn't answer, but it's one side of that big problem. I was working with a very large retailer, not the one I mentioned before, and they wanted to estimate if advertising works. Can you put a number on a campaign to say if it works? And we worked a lot with very high, very good experts on the team, you know, for a year, came up with a model, implemented it, and then they refused and they killed the project because the numbers were very low. And they said, we can't give these low numbers to our customers. So it would have required a lot of high-level decision-making to say, no, we believe in that, that's the data, we're data-driven. It was impossible because it was killing their own business. So that's one side. And so I just don't have an answer because I think, though, when I look at it from the bench as a data scientist, there's a lot of onus on us to really provide solid results. Too often do I see that it's half-baked. For example, there's a technique which is very simple. When you have an algorithm, okay, you have your input data, shake it, destroy a little bit, shake it to make it like fragile, input fragile, and see if your results hold through the storm. And that process is computationally long, it's hard, it's a hard sell, and people want to go fast, so often it's bypassed. But I really think that's on our side, data scientists, to provide very solid result, reproducibility, and so on. But in the end, myself, I don't fully trust data. I mean, I think we should have a healthy mistrust and require more. For example, A/B testing often is used in a way that it's fine if the two groups that you're comparing, the ones you treat and the ones you don't, they must be the same, right? If they're very different, there's a bias, and so it's I don't know how to answer your question, basically.
Just a follow-up question on one. So you're able to rank like the different features, right? And are we technically able now to basically rank the combination of the exhaustive ranking of all the combination of factors?
So if I may rephrase your question, it's like when you have, say, 100 features, you could look at each feature and rank them, or you could say, oh, how about this list of 10 features versus that list of 10 features? I have so many lists of different 10 features, I would still want to rank them. And that becomes, as you guess, a very complicated problem. But there's hacks that work pretty well to tell you at least if you have, and that's what I use for text when I provide 50 words that characterize this or that writer. Those words are a list. It's not like I pick a first word and then I look next word. It's combined. So what you're saying is that it's a big, very difficult combinatorial problems, but there's a very good hack to address it.
And Laurent, did you say that they can try out some of the text analytics features on your website?
Yes, so I can send the link and the password, so welcome to try. It's in development, so don't expect like a Uber new shiny interface. It's just a little bit bare bones, but I'd be very curious about your comments there.
Okay, well, thank you.
So I'll forward you.